In this tutorial, we're going to talk about environmental coherence. We will talk about relative physical properties, relative visual properties, and also relative semantic properties. So first, for this demo, I'm working with this simple home stuff free asset off of the Unity asset store. You can see the environment here. The first thing that I'm going to do, it already includes an orthographic main camera, which I'm going to delete because otherwise that causes problems with the XR rig. I'm also going to create a simple empty game object. I'm going to rename it virtual environment. And I'm going to go ahead and select all of the other objects and make them children of my new virtual environment object, so I can quickly collapse and manipulate the virtual object. I'm going to go ahead and add an XR rig. So the XR rig is now added into the scene. I need to set up the XR rig with the XRST simulation. So that includes adding the XRST controller to each of the controllers, adding the XRST rig to the rig, and adding the XRST shortcuts to the rig. Okay, so this should be set up now, and if I press play, you should be able to see what's going on. So you'll immediately notice from this perspective, my player character appears to be a very short character, and that is due to the fact that the virtual environment is too large. It's also the case too that I haven't set the larger tracking space on my virtual rig, so therefore I'm limited in terms of walking. So let's go ahead and fix that first. So we'll adjust the tracking radius to something very large that I'll never reach. And now let's rescale our virtual environment, because as we saw from that demonstration, our virtual environment is clearly too large. So the first thing I'm going to do, I'm actually going to add a plane as a reference object to just help me out. And let's center this at 0, 0, 0, same place where my XR rig is. And one thing that we'll quickly notice by doing that is that the virtual environment is actually too low. It should be moved up. Now, the other thing that we need to do is to scale the entire virtual environment. Now, by default, I know that, or from experience, I should say, I know that counter heights are approximately 1 meter. So I'm going to simply add a cube into the environment. We know that that cube by default will be 1 meter by 1 meter. However, notice it's going into the plane. That's because we need to move, it's centered with the 1 meter by 1 meter, so therefore it goes half a meter up, half a meter down. So we need to position it half a meter up to make the bottom of the cube align with our plane. That looks great. And we can see from here that our virtual environment is clearly too large. This countertop is easily 2 to 3 meters. So let's go ahead and start scaling our virtual environment down. That looks like it might be approximately correct. But let's move the virtual environment so that we can actually get an idea. So it does need to be scaled down a little bit more because it's still, the countertops are still higher than my cube. That might be more correct. Let's take a look at that. We'll actually focus in on my cube. And if we grab the entire environment and move it around, and keep in mind, currently it's a little too tall because I cannot see my plane. So I'm going to lower down. And that is nearly perfect. So our countertop is approximately 1 meter tall. Same as the cube. And just to help out here, I'm actually going to position us so that we're approximately starting the same place that we did before. And now that I no longer need these, I can actually remove the plane and the cube. And if we play this, My user no longer appears to be a small individual. Instead, he is towering above the kitchen table. As he looks around the virtual environment, everything else looks about the correct height. He can look down at the stove. He can look down at the sink. So we have fixed basically the relative scale problem of all of these objects. Now, another thing to consider is let's assume that I want to add a mug here to my environment. Let's say I want to put a mug on top of the kitchen table for the user to pick up and simulate drinking coffee, for example. So in a previous tutorial, I had worked with a cat mug. I've already brought that cat mug into my project, and I've also created a prefab for it. And by default, normally if objects have colliders, you can actually just drag your prefab into the scene, and wherever the collider is, the prefab will sit on top. But you'll notice my mug is not sitting on top of this table. That's because the table doesn't have any type of collider representation. So for now, I'm actually just going to remove this mug, and let's actually go in and add a collider to my table. The way that this artist created this particular environment, they actually made the chairs children of the table. I believe they did that so that they could easily move the set around, although that is not correct in terms of being able to interact with the environment. So I want to move these chairs above the table. Because the table is a prefab, I have to break the prefab by basically unpacking it. So I'm going to completely unpack it, and now I can move the chairs out. And I can also add a box collider to my table, and now I should be able to drag my mug on top of the table. Great. And let's take a look at this. Actually, let's rotate my mug 90 degrees so that when I look at it, I can see the front of the mug. And if I look down, turn a little bit, let's say I strafe right a little bit, the mug looks great. However, what you should notice is that the mug doesn't look like anything else in the virtual environment. Nothing else in my virtual environment is currently textured. Nothing else is as high poly as this mug. So this is an example of where the visual relative properties of the objects are not consistent. Basically, this mug is textured, it's high fidelity, it's got a lot of curvature to it, while all of the other objects are very rectangular, cuboid, they lack texture. So this is what we would call an example of an inconsistent virtual environment. So how do we fix this? Well, one would be to basically choose to use a higher fidelity scene. But for this particular example, the easiest thing is to use a low poly mug. So I'm actually going to remove the mug that we just added. And inside of my assets folder, I also have the office environment that we've worked with before. And inside of the prefabs and the props for it, there's also a coffee mug. And if you recall, that coffee mug is a little lower fidelity. So let's rotate it. And now when I play this, and when the user looks down, notice that mug actually appears as if it belongs in this environment. It is not textured. It is clearly much lower poly, as you can tell the curvature, you can tell the angles used to create the circumference of the mug. And this creates for a consistent virtual environment. And that's very important. You want to make sure that in general, if your virtual environment is based on high poly assets, that you try to attempt to make sure all of your assets are high polygon, high fidelity, at least moderate to high fidelity, and you want to avoid low polygon objects. On the flip side, if your environment is primarily a low polygon virtual environment, you want to steer away from high polygon features, assets, high fidelity assets, because essentially they'll draw attention to the user that the developer didn't take the time to make everything consistent. It breaks the aesthetic feel, and it will break that sense of presence or being there within the virtual environment. Now, one last thing I want to demonstrate here. I don't know if you've noticed this before, but essentially, there is no ceiling to this virtual environment. And that obviously is very problematic. So almost every single indoor environment that you'll ever see will have a ceiling, because otherwise, when it rains, all of your electronics and things would get wet. So we need to add a ceiling to this virtual environment. So let's go ahead and do that. The easiest way to accomplish this is to actually simply add a plane. Let's make sure that plane, let's work with 0 for now. Make sure the bottom of our virtual environment aligns with it. Yes, it does. Now you'll notice that currently our plane is not large enough to cover the entire virtual environment. I believe I can fix this very easily by giving it a uniform scale factor. This is too large, but keep in mind, if the user stays within doors, it doesn't really matter. So that very easily will cover the ceiling. In terms of height, depending on the ceiling heights can be anywhere from 8 feet to 10 feet. I'm going to just assume a nice even approximately 9 feet, which would basically put the height around 3 meters tall. And currently with the plane primitive inside of Unity, there is a single surface normal on this side, but on the back side, there actually is not a surface normal, which means I still don't appear to have a ceiling. So the easiest way to fix this is to simply flip the object 180 degrees about its x-axis. Now the nice thing is we can still see down into the virtual environment because there's not a back face, but when we're inside of the virtual environment and we peer up, there is a ceiling now, which is great. So let's take a look at this. Now, one thing that you'll notice is we do have a ceiling. However, our walls are actually too short. This is another example where the semantic properties of the object and the physical properties of the objects do not coincide with one another. And this creates for an inconsistent virtual environment. Now, luckily, this problem is very easy to solve because the walls are fairly independent. In this particular case, I can just select all of the walls. And I can simply scale them up. The nice thing here, pay attention, is that none of the walls act as intermediate branches. In other words, they do not have any children. So they are leaf nodes, so I do not have to worry about them having a uniform scale. And I can simply just scale them up until I'm pretty sure that they've hit the roof. And now if I play this, we have gotten rid of that gap. It looks like I have a clear ceiling. The height of the virtual environment appears clear. All of the assets appear to be low poly assets. So in general, I now have a virtual environment which is very consistent. It's consistent in terms of the physical properties, its visual properties, and its semantic properties.